How's it going, guys? Today in this video, we're going to be going over 11.2, day 1, where we're going to be going over how to graph square root functions. So in the past, in this course, we did study imaginary numbers and how to get them from square roots of negatives, but trying to graph imaginary numbers is way too complex for this class, so we're not going to go over that. So when we're trying to graph the parent square root function, we need to make sure that the domain and range are limited to the non-negative real numbers. So the square root function, we've talked about this in previous sections and previous lessons, that is the inverse of a quadratic function with a domain limited to x being greater than or equal to 0. Right? We need to make sure that the quadratic is, we're only using half the quadratic to make sure that the inverse of that quadratic is actually a function. So what we're going to do now is we're going to fill out this table to figure out what the parent square root function looks like. So we have these x values here. We're going to plug them into our f of x, which is just the square root of x. So we're essentially just going to be taking the square root of all these x's. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So we have all these points, 0, 0, 1, 1, 4, 2, and 9, 3. We're going to graph them and see what our parent function is going to look like. 0, 0, 1, 1, 4, 2, and 9, 3. So our function, it's a very ugly line, very ugly graph, but it should look something like that, just not so bumpy. So the domain, we see that our smallest x value is right here at our, I guess you call it the vertex of 0, 0. So we start at 0 and we go to the right forever. So that means our smallest x value is 0 and our biggest x value is infinity. So our domain in set notation is every x value such that x is greater than or equal to 0. And for the range, we start at this point right here. We pretty much just call it the vertex. It's 0, 0, so our smallest y value is 0. And this graph is always increasing, it's always going up and right. So it's always, the y values are always increasing. So that means our smallest y value is 0, and our biggest y value is going to be infinity. It's always going to be increasing. So our range is every y value such that y is greater than or equal to 0. So the graph gets flatter as x increases. That means the rate of change is decreasing as x increases. Or in other words, the slope is getting much, much smaller, is getting much steeper as or not much steeper, but it's going much flatter as the graph goes on. So we're going to describe the end behavior of the square root function. So what the end behavior is going to be is that f of x goes to infinity as x also goes to infinity. So that's what the end behavior is of the parent square root function. So on this page here, we have our transformation rules. And it's pretty much the same thing as we've always seen in the throughout the whole year. Our A term gives us a reflection over the x-axis, and it tells you the vertical stretch or compression. The B term will give you your horizontal stretch / compression, and it'll give you if it's a reflection over the y-axis or not. Our H is a horizontal shift left to right, and our K is a vertical shift up and down. So for these next, looks like it's about 12 problems here, the transformations here. I want you guys to pause the video and try doing it on your own to give you guys a little refresher on how these transformations work. So the first one is a shift right by 2. Then we have left by 2. The next one, we have a shift down by 2. And the fourth is a shift up by 2. Then we have a vertical stretch by a factor of 2. A vertical compression by a factor of 1/2. And then on the last one on that column, we have a vertical stretch by a factor of 2 and a reflection over the x-axis because of that negative. On the next column, the first one is a vertical compression by a factor of 1/2, and it's also a reflection over the x-axis. Next, that's a vertical stretch by a factor of 2, then a horizontal compression by a factor of 1/2, Then we have a horizontal stretch by a factor of 2 and a reflection over the y-axis. And the last one is a horizontal compression and a reflection over the y-axis. It's a horizontal compression by a factor of 1/2. So let's talk about actually how we're going to graph a transformation of our parent square root function. And we're going to do that by looking, or rather, by using 2 reference points, 0, 0, and 1, 1. We only need these 2 points to figure out what our transform function is going to look like. So when we're transforming these points, we have this function here. We're going to get our a, b, h, and k from our function. And from that, we're going to put that either into our normal transformation rule that we see throughout the year, bx plus h and ay plus k. But you don't really need to do it in this case here, since we're only using 0, 0 and 1, 1. That transformation rule for the initial point of 0, 0 will just be hk. Your hk will give you your initial point, and your second point of 1, 1 will come out to b plus h, comma, a plus k. And that's because the x and the y in your transformation rule either becomes 0 and goes away, or it's a 1, so the x and y just go away, and you're left with just b and a. So anyway, when you change the transformation of a square root function, you're also going to be transforming or messing with the domain and range as well. So the one thing we need to make sure of is that the domain must always give non-negative values underneath the radical or underneath the square root. Like we said from the beginning, we don't want to deal with imaginary numbers, so we need to make sure that everything underneath the square root is always going to be 0 or positive. It cannot be negative. Well, it can be, but we don't want to deal with that, so make sure it's always a non-negative number, either 0 or a positive number. So for our domain, if b is greater than 0, or in other words, when b is positive, our domain is x will be greater than or equal to h. And that's because when b is greater than 0, we have this function here. Let's just say it's the parent function. It's going to be going this way. It's going to be going to the right. But if b is negative, it has to be greater than or equal to. If b is negative, that means we're reflecting over the over the y-axis. So if b is less than 0 or it's negative, our new function is going to be facing towards the left. We're reflecting over the y-axis, so we go from going to the right to going to the left. So that's why x will be less than or equal to your h value, because the initial points of where these start, the x value of it will be your h points. And we'll see what I'm talking about when we go through a couple of examples. Next, for our range, if a is greater than 0 or if a is positive, your y value will be greater than or equal to k. And that's because if a is greater than 0, we're not reflecting, so that means we're just going to be just going up. But if a is less than 0 or if a is negative, your range will be y is less than or equal to k. And that's because if a is negative, that's a reflection over the y-axis, or sorry, over the x-axis. And if we're reflecting over the x-axis, that means we're going to be going downwards like that. So instead of going up, if a is positive, the graph will be going up. And if a is negative, the graph will be going down. If b is positive, the graph will be going to the right. And if b is negative, the graph will be going to the left. So that's why you have these domains here, because your h and k come from your vertex or your initial points, and your domain and range will come from that. Because that point will either be the smallest point of the graph or the biggest point of the graph. So let's keep on going. So you actually see what I'm talking about when I say the domain and range depend on your a and b. So on example 1, we have our a value to be 2, our b is 1, our h is 3, and our k is -2. So first thing you want to do is you want to find a domain. So there's really 2 ways I want to go over with finding a domain, and that's the first one will be setting everything underneath the radical or underneath the square root to be greater than or equal to 0. For our purposes, we always want everything underneath the square root to be greater than or equal to 0. We want it non-negative. So we set this to be greater than or equal to 0, and we solve it out. we get that x is greater than or equal to 3. So that's one way to do it, to find your domain. The other is to see that b is positive. It's greater than 0. So if b is greater than 0, that means we didn't flip it over the y-axis, so we're still going to the right. So that means x has to be greater than or equal to your h points, which is 3. For our range, we can see that our a is greater than 0. It's a positive number. It's 2. So if a is a positive number, that means our y will be greater than or equal to our k term, which is -2. Right? If a is positive, we did not reflect it over the x-axis, so that means it's still going up. The graph is still increasing, going upwards. So now that we have our domain in our range, what we want to do now is we want to find our transform points. So for 0, 0, that's just going to give us hk. So we plug in our h and k terms, we get 3, 2. For 1, 1, we have b plus h, comma a plus k. If we plug that in, our b is 1, and our h is 3. Our a value is 2, and our k term is -2. If you add these up, we get 4, 0. So we have our 2 points, and what we want to do now is we want to graph both these points. So the first one we have is 3, 2. That's our initial point. That's right there. And our other one is 4, 0, right there. Let's actually do this in a different color other than black. Make it a little easier to see. 3, 2, and 4, 0. So when it comes to graphing your points, once you have your points on the graph, and when it comes to graphing the actual function now, we always want to start our function at our hk point, or in other words, at our initial point that came from 0, 0. So our 0, 0 transformation, it gave us the point 3, 2. So that's where we start, and we're going to go from there. And that's because this 3, 2 point is a transformation of your initial point there. The 0, 0 point transformed into 3, 2 in the new function, so that's why we have to start at that point 3, 2. Because it transformed from 0, 0 to that 3, 2, so that's our initial point. That's where we start. So that's what our function is going to look like. So let's go on to the next slide, the next example. And on this slide, we have the square root of -1/2 x minus 2, all plus 1. So our a term here is 1. Our b is -2, right? It's -1/2 is 1 over b. So our b is going to be -2. Our h is 2. And our k is 1. So we have our a, b, h, and k. Now let's find our domain. So again, there's 2 ways to go about finding our domain that I want to talk about. We can either set everything underneath the radical or the square root to be greater than or equal to 0. And we can solve it out this way. So to get rid of that -1/2, we're going to multiply both sides by -2. And anytime you multiply an inequality or an inequality by a negative number, you flip the inequality sign. So we get x minus 2 is less than or equal to 0. 0 times -2 is still 0. And then we just add 2 over, and we get that x is less than or equal to 2. So that's our domain, going about it that way. The other way is to see that our b is less than 0. So if b is less than 0, our domain will be less than or equal to our h term. So x is less than or equal to 2. We got the same thing either way, but the red way is just a little quicker, especially if you can kind of see it right away. You'll get your domain right then and there. So it is much quicker to just know your properties. For your range, we see that our a is a positive number. It's greater than 0. So our range will be greater than or equal to our k term of 1. Right, if a is positive, that means we didn't reflect it over the x-axis. So that means we're still increasing, going upwards. So we have our domain and we have our range. Let's go ahead and find our transform points. 0, 0 goes to hk, which gives us 2, 1. Our h is 2 and our k is 1. For our other points, 1, 1, our b term is -2. Our h is 2. Our a is 1, and our k is also 1. So that transforms into the point 0, 2. So now we have both of our points. we can graph that on the graph so we can figure out what our new transform function will look like. We have 2, 1, and we have 0, 2. So again, we need to start at the point that starts at 0, 0, or HK. So that's going to be our 2, 1, and we're going to go that way. And again, we start at that point of 2, 1 because we see that 0, 0 transformed into 2, 1. So our initial point here transformed into that point there. So that's why we have to start at our initial point that came from 0, 0, or in other words, your HK points. And that's what our function is going to look like, and it lines up with what we kind of could have saw from the beginning. Our A is positive, so that means we have to be going up, but our B is negative, so that means we have to be going to the left. It got transformed over the, or not transformed, but reflected over the y-axis. So instead of going to the right, we are now going to the left, and that's exactly what we have in our red function. So we're good to go. All right, let's go over number 3. Number 3, we have an A value or a value of -3. Our B is 1, our H is 2, and our K is 3. First thing we're going to do is find our domain. So we see that B is positive. So that means our our domain will be x is greater than or equal to 2. For our range, A is less than 0. It's a negative number. So that means our y is less than or equal to our k term of 3. So we find our domain and our range pretty quickly by just knowing our properties related to B and A. So now we're going to find our transform points. We're going to use our 2 reference points we talked about before, 0, 0, and 1, 1. So for 0, 0, that's going to give us, or so it's not going to give us, but it comes from HK. Our H is 2, and our K is 3. So that's 1 reference point, or 1 transform point rather. And for 1, 1, that's going to come from B plus H and A plus K. So when we transform that point, our B term is 1, our H is 2, our A is -3, and our K is +3. We add that up, we get 3, 0. So we have our second point now. So let's go ahead and graph both these points and figure out what our function is going to look like. 0, 0 goes to 2, 3. And 1, 1 is going to go to 3, 0. So we start at our point 2, 3, since that came from 0, 0. So our function will look like that. Well, not exactly like that. I didn't really go through the points. Let's do that one more time. 2, 3, 3, 0. Still didn't get it, but oh well. That's what it should look like. It should be going down since our A is negative. So we'll be decreasing, going downwards. Our B is positive, so we're still going to be going to the right. So our X's are still increasing, while our Y's are decreasing. All right, so that's number 3. For number 4, I want you guys to pause that on your own and try to work it out on your own. And then in a few seconds, I'll post the completed answer, and you can double check your work with that. Okay? So this is what you should have gone for number 4. Your A is 1, your B is 3, your H is -2, and your K is 1. So your domain should have been x is greater than or equal to -2, and your y should have been your range should have been y is greater than 1. All right. So for our transform points, 0, 0 should have given you -2, 1. That was your H and K terms, and your 1, 1 should have given you 1, 2. The first one is B plus H, 3 plus -2 is 1, and the second one is A plus K, 1 plus 1 is 2. So that's what our transform points will be. We plot them into our graph. Your 0, 0 transformed into -2, 1. So this point right here is your initial point. It came from 0, 0. So we start from there and we go to the right because you have to connect to the other point of 1, 2. And that's what our function, our transform function anyway should look like. So that's the video, guys. Hopefully it helped.